Hi, today we'll be looking at how you can deploy resources to a Kubernetes cluster using YAML files. So we will start by learning the basics of the Kubernetes YAML file, what are some basic components of the file, and how you can create different type of resources. Then later on, we will deploy some of the resources to a Kubernetes cluster running on the AWS cloud. So an EKS cluster, also known as Elastic Kubernetes Service. Hi, I'm Rishabh. This is Rishabh in Cloud. Let's get started. So if you're not aware, this is part of the DevOps Capstone project. So this is the entire DevOps Capstone project playlist right now, and this will be part 6 of that series. In this series, we will be building a DevOps project covering various principles like infrastructure as code, CI/CD, containerization, of course, Kubernetes, and also monitoring and observability. So I'll make sure that the playlist link is in the description. But now let's get back to Kubernetes. So talking about that series, in the last video, we deployed a minimal EKS cluster to AWS using Terraform. So if you want, you can check that out. But that is why I have this main.tf open here. So the EKS cluster is already deployed to the cloud. But before we dive into creating our own YAML files, let's look at the YAML file structure and some basic components. So the basic structure of the file looks like this, where you have the API version on top, which specifies the Kubernetes API version to be used to create this object. So it could be v1, it could be apps/v1. Then we have the kind, which defines the type of Kubernetes resource you are trying to create. So this could be a pod, a deployment, or a service. Now going with metadata, this contains the metadata about the resource that you're creating. So things like name, namespace, labels, those all go under the metadata. And the last thing is spec. So spec defines the desired state of the resource that you're creating. The content varies based on the kind of resource you're deploying. So if it's a deployment, the spec will have different properties or components. And if it's a service type resource, the spec will obviously look different to that of the deployment. So now that we have that covered, we'll look at some common resource types. So for the first one, we have the pod. So if you have to create a pod, this is how the spec will look like for the kind pod. So you can see we have containers within our pods, and I have named that my container, which is using an Nginx latest image. Then we have deployment. So this one is crucial because this is what we'll be using today. So with the deployment, under the spec, you can see that you can have amount of replicas for the pod. So if you want 3 pod replicas, you can have replicas set to 3. You also have the selectors. So this is how the deployment finds which pods to manage. Then for our container, as you can see in this example, I'm using my container as the name and Nginx latest again as the image. And that all goes under the template under spec for our deployment. So this is the pod template that will be used to create 3 replicas for us. Now for the service, which is also another important one because we'll be using this, you can see the kind is set to service, and then we have the type of service within spec, which is set to cluster IP. So this means that we also have to define some ports for our service. So here you can see the protocol is TCP. We are exposing port 80 and the target port is 9376. This, of course, will change depending on your application. So if you're using, node.js and you want to create a service for your pod running node.js, these settings can be changed accordingly. We also have the selector under the spec, which defines which pods are part of this service. So in these examples, you can see the app is always set to my app. So the service knows which pods are going to be part of this service. For the types of service, the other important one is load balancer. That is how you expose your application to external traffic. So just keep in mind that we'll be using cluster IP and load balancer today. And then there are some other resource types like config map and ingress. Again, this is more of focusing on the DevOps Capstone project. This in no way is a Kubernetes crash course. So if you're not familiar with Kubernetes and don't know about all these different YAML file examples that I'm sharing, please I would suggest that you step back and learn about Kubernetes and the basics first. Let's keep moving forward. The other key concept I wanted to cover is the multi-resource files. So you can define multiple resources in a single YAML file by separating them with 3 dashes. So here you can see we have a service on top, and then we also have a deployment resource type within the same YAML file. So now that's out of the way, let's come back to our DevOps capstone project. So as I said, we already have a cluster in AWS. So I can quickly log in to my AWS console. And as you will see within my EKS dashboard, we have the DevOps capstone project, which is running a 1.28 Kubernetes version cluster. So we are good on the cluster. Now coming back to our project here, just to give you a brief history, we have a front end, which is in Next.js, and we have an API, which is written in Fast API. So the front end accepts a URL, so users can enter a URL and then they can generate a QR code. The generation of the QR code is handled by the API. So those are the 2 components of the application. And the other thing that's already taken care of is the Docker images. So that's why I said check out the previous parts, because we have covered all of this. Both of these folders have a Docker file. And also we have a GitHub action that is running the CI/CD pipeline to build those images and publish it to Docker Hub. This is my personal Docker Hub account. And as you can see, I have the QR code frontend and QR code backend images, which we'll be using today. So let's go ahead and write some YAML. So within my root of this project, what I'm going to do is create frontend.yaml. This is where we will define the front-end deployment. So if we go back to the example that I was sharing earlier in my notes, I'm going to copy that and paste it here. And we are also going to replace the names and the images that we are using. So as you can see, I have the front-end YAML ready. To reiterate, this is a deployment resource type. For the metadata, I'm going with QR-frontend. We have 2 replicas under the spec. We also have the selector where the app is set to QR-frontend. And for the template, we are using the containers named QR-frontend along with the image. So I just copied this Rishabh-Kumar7/DevOps QR code frontend from my Docker Hub account. So if we go here, you can see it has 1 tag that is the latest. So we'll be using this. And then we are exposing the 3000 port because that's where my Next.js app will be running. Awesome. So now that we have that, we can do the same for the backend. And we'll call this backend.yaml. And like before, this is a deployment type. The metadata for name is set to QR-API. Or we could also name this QR-backend. I'm just going to go with API for now. For the replicas, I've set it to 2 again. And we have the app set to QR-API. The template that I'm using for the container for 2 replicas is the name of the container will be set to QR-API and then some random string. And the image is set to the backend image from my Docker Hub account. Awesome. The other thing to note is since both of the images that I have in Docker Hub are public, I don't have to worry about the authentication here. But if you're using your own personal registry, like ECR from AWS, which is Elastic Container Registry, you'll have to figure out the authentication and authorization to pull that image for our deployment within the cluster. So now what I can do is open up my terminal here. And in order to deploy this, what you have to do is make sure you have kubectl installed, which is the command line tool. So if you don't have that, please make sure it is installed. And in the previous video, I already covered on how you can configure your kubectl to talk to the EKS cluster. So I can show you if I do kubectl get nodes, it'll pick the 1 node that I have in AWS running, which is this, which is running 1.28 version of Kubernetes. So now what I can do is kubectl apply -f, and let's do the front end first. So kubectl apply -f and the YAML file. In this case, I'm doing front end first. Similarly, I'll do for the backend. There we go. Now, if I do kubectl get nodes, if I do kubectl get pods, we should have 4 pods because we have set the replicas to 2 for each. And as you can see, we have the QR API pods and we also have the QR frontend pods running. Now, we are not able to access both the frontend and the API because we haven't created a service yet. So we'll create a load balancer type service to expose our front end only, because I don't think we need to expose the API. But if you have other needs for your own application, please, you can expose both of them. I think it is more secure that our API is not exposed, but we'll have to make sure that both of the pods can talk to each other. So the front end can talk to the back end. So within our front end, we'll launch a new service. So what I'm going to do is use that multi-resource files. So 3 dashes. And now here I can define my new service. So let me make sure I'm in the front end, go to the bottom, and then have 3 dashes. And now I can define the resource type service. So we'll be using v1. The spelling of version is incorrect. And we'll use the kind as service, as we saw that in an example. Well, I'm going to copy from that example and change the values. Okay, there we go. So I have the metadata where name is set to QR frontend service. Then I have the type set to load balancer because we want to expose this to the public, or it should accept, public traffic. And then the selector is set to QR-frontend because that is what the name is of the app within our deployment, so it knows which pods the service is for. For the ports, I'm using the TCP protocol. The port on this load balancer that will be exposed is 80, but the target port on the pods is set to 3000 because I said that is where my Next.js app is running on the pod. So I'm going to hit save and open my terminal again. And now we can do an apply for the frontend.yaml. We'll see that the deployment has been unchanged, so it won't change anything on there. But it saw that the service is added towards the end, so it has created that service for us. Now, if we do kubectl get services, we should be seeing the load balancer type service, and we also have an external IP, which is the domain name of our load balancer from AWS. So since EKS is a managed service, all of this creation of new resources after you deploy them using kubectl apply is handled by AWS, and hence it created a public-facing load balancer with the necessary security group and settings already in place, which is, awesome. It takes away a lot of the headache from you. So now, if we go to this address, we should be able to see our Next.js application. So it'll take some time for DNS to propagate, as you can see. There we go. As I was talking, we do have our front end working, but we shouldn't be able to generate QR codes yet because we haven't made the connection between the front end pod and the backend API pod yet. So in order to do that, we'll create a new service for our backend, and this will be a cluster IP so that when the front end sends the request to API, it knows where that API pod is running. So now I have a service within my backend, and as you can see, this is called QR API service. It's a type of cluster IP. The apps selector is set to QR-API because that's what we named the pods in the deployment. And for protocol, it's going to be TCP again, but the port that the service is going to listen on is 80. And also the target port for this is 80 because I know that my fast API utilizes port 80. So I'm going to do Control S, open my terminal again, do kubectl apply -f on the backend file, and same thing is going to happen. The deployment is unchanged, but it created a new service. Now, to verify, we can do kubectl get services, and we'll see that we have a cluster IP for our QR-API service. Awesome. But I still don't think that it'll work, and I can show you if we do create a QR code for example.com. I'm also going to open the network tab just to see what happens. Click on generate QR code, and you can see that it didn't generate the QR code. If you go to console, you can see it says the name not resolved, because if I go to my Next.js code here, we'll see that this is set to localhost. But instead, what we want is the service address. So this is where our API is running. It's called QR-API-service / generate QR code is the endpoint that my fast API listens on. So now I'm going to hit Control S, but we'll have to build a new Docker image, push it to Docker Hub, and then roll out the deployment. So I'm going to quickly do that. So I CD'd into my Frontend Next.js app. I'm running the docker build command. Now I'll do a docker push so that this pushes the image to Docker Hub. Okay, now the image is pushed. What we can do is kubectl rollout, restart, and then do a deploy for our frontend, which is qr-frontend, hit enter. And as you can see, the deployment for our QR frontend has been restarted. So if I do kubectl get pods, we can see that the QR frontend pods just started because they were replaced. So the old pods were shut down and then the new ones were created. And you can tell that by the age, so 9 seconds and 11 seconds. So let's go back to our load balancer domain name and hit refresh. And now we can try generating the QR code. And as now you can see, it is going to the QR-API service / the generate QR endpoint, but within our console, we are still getting the name not resolved, even though we have the cluster IP service set up for our QR API service. So this should resolve to the IP address of our pod. But what I just realized as I'm going through this is I didn't specify the container port within our deployment. So remember in our front end, we do have the container port set to 3000, but here we don't have anything. So for our backend, we do need that, and that is port 80. Now if I could do Control S.
A few moments later.
Okay, so after some debugging, I realized what the issue was. So for our Next.js application, we had the URL for our backend service, which was our API, right? So that is our backend here. And as you can see, I have changed the URL now to just have the endpoint, which is /API/generateQR. The reason hard coding the backend service URL was not working is because this is client-side code. So as you can see on the top, our page.js has the use client, which means, all of this is client-side, meaning this is from the browser or from end user's browser, right? So the HTTP QR backend service was the name, or QR-API-service was the name that was allotted with the cluster IP, right? That would not translate for the end users, right? Because end users don't have access to the internal network of our cluster. Hence, we were getting either the connection timeout or the name could not be resolved because for the end user, the IP or the DNS name doesn't make any sense since they don't have access to the internal network. So for the fix, what I have done is I've created the API route within my Next.js app. Again, all of this will be in the GitHub, so you can make these changes to your own Next.js application. So I created a new directory called API, and I have a new folder called generate-qr, and that has a route.js. So basically, this is server-side code for Next.js. And what it is doing is any of the requests in our page.js, which is client-side, any of these requests that go to API/generateQR will be forwarded to our backend cluster DNS name, or you could also hardcode the IP here. But since I know that my backend service is going to be named QR-API-service, and I can make sure that the backend.yaml always has that, it is going to work because now the DNS translation will happen on the server side, which is our front-end container, who does have access to our Kubernetes cluster network. And some other things that I've done, of course, is to rebuild the Docker image, push it to Docker Hub, and also do a kubectl rollout for the front end. Now this should have our new Next.js app running with an API route. So what I can do is do get services, and this will give us the URL for our load balancer. So let's try visiting that now. And I'm gonna open the network tab in the developer tools, and let's go with example.com, generate QR code. And as you can see, it is working. And you can also see that the request was sent to the API route. So we don't have our backend service URL here, which is awesome from security's perspective. As I was debugging, I just realized that, wait, all of my Next.js code so far is just client side, and client side won't have access to my internal Kubernetes cluster network details. Hence, I made those changes, created an API route, which basically has some server-side code. And for server-side, this will translate because the container has access to the network. Awesome. So now we have our front-end and back-end running in Kubernetes cluster on AWS, specifically EKS, and we can generate QR codes. And that was the goal of this video. So I hope you find this one helpful. I know there were a few hiccups, but I am glad we ran into those because this gives me a chance to show you how to debug and, make those changes. And I think it gives a good reasoning and understanding behind how all of this technology works, specifically with containers, the client-side and server-side code, and also how the API works. So I hope you found this video helpful, and I'll see you in the next one where we'll set up some monitoring and observability for our EKS cluster. So yeah, stay tuned to the series, and peace.